octet rule, write its significance and its limitations. So take down the octet rule. What does octet rule say? It says that atoms give, take or share electrons. Atoms give, take or share electrons in order to complete an octet of electrons in their outermost orbit. In order to complete an octet of electrons, that means a number 8 of electrons in their outermost orbit. This is the simple statement of octet rule. Fine. What about its significance and limitations? You can do them very easily. Number 1, why is octet rule valuable? Why is it important? Octet rule is very important because it was the first rule which gave us an idea about how atoms combine to form molecules. So the rule which gave us the first method of how to write down molecules with the help of atoms, some guidelines, this was the rule. That is a very major significance, and still octet rule is very popular in writing down the structures in organic chemistry. Organic chemistry largely contains carbon, hydrogen, oxygen, nitrogen, such atoms, and for them octet rule works very well. This is the significance of octet rule. Second point. The third point says the limitations of octet rule. Oh my God, octet rule has so many limitations. Let me count them one by one. Limitation number 1. Octet rule is not valid for hydrogen or helium, that is first period elements. For them only duplet is there, only 2 electrons, not 8. Fine. Then for second point hai, for second period elements, octet may remain incomplete in such cases. Octet may remain incomplete in some cases like BF3, BCl3, BeCl2, BeH2, especially atoms of beryllium and boron. Whenever they form compounds, often they have incomplete octet. And such compounds are called hypovalent. Hypovalent. You know, the ones which have lesser number of electrons than what is required. But yes, are they formed? Yes, they are formed. Compounds like BF3, BeCl2, they are exceptions to octet rule. Octet rule doesn't work with them. So for second period elements, atoms tend to complete an octet, yes, but there are certain molecules, and especially the molecules formed by beryllium and boron, which have incomplete octet. Fine. Third point, third period onwards, octet rule may or may not be followed. Oh my God, what does that mean? It means that octet rule is totally at the mercy of atoms. Atoms, if they feel like, they follow octet rule. If they don't feel like, they don't follow. What is that? It's simple. Like say, for example, if you have PCl3, PCl3 follows octet rule and PCl5 does not follow octet rule. As a matter of fact, phosphorus in PCl5 contains 10 valence electrons, which is, more than 8. Okay, I'll just draw the structures and show you. PCl3 is like this. So 2 plus 2, 4 plus 2, 6 and plus 2, 8. Phosphorus is following the octet rule and so does each chlorine atom. What about PCl5? If you have PCl5, Cl, 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 Cl. Chlorines are following the octet rule. But if you notice phosphorus, shamelessly it has formed 1, 2, 3, 4, 5 bonds. Each bond contains 2 electrons. That means phosphorus has 10 electrons. Oh my God. In such a case, we say that whenever any atom has more than 8 valence electrons, we say it has an expanded octet. So phosphorus shows an expanded octet. It is also called hypervalent. You can call it hypervalent, you can call it atom having an expanded octet, but yes, that is the case. So third period onwards, octet rule may or may not be followed. Sometimes atoms follow it, they just keep 8 valence electrons. Sometimes they may expand the octet and they may include more than 8 valence electrons also. And fourth point, in D and F blocks, octet rule is nearly never followed. There is no respect for octet rule if you talk about D block elements or F block elements. They don't care absolutely for octet rule at all. These are the limitations of octet rule. And just as we move ahead, one small observation. Please remember, students, octet rule does not work for more than 60 to 70% compounds you will come across. So it is just a generic rule. Had octet rule not been so popular in organic chemistry, we might simply have not been mentioning it also. But since it works very well for organic molecules, I mean, it is there, just enjoy it.